Hi, in previous videos, we worked on calculating amounts accrued when we use compound interest or continuously compounding interest. And in this video, we're not going to look for the amount that's accrued. Perhaps we will plug in and start with some desired accrued amount. So say I want to have $1 million in 10 years. How much do I need to invest now? So this is called a present value problem. Okay, so remember our equations from before. If we have compound interest with rate R, and we're investing it for T years and compounding it M times per year, then we can calculate the amount that we are going to end up with as A equals P times 1 plus I to the N, where N is the number of times it's compounded and I is R over M. Okay, so that's our formula here. And so far what we've done is plugged in P, plugged in I, plugged in N to find A. However, we know that we can just plug in all but one variable and then solve for that one variable. So if I want to end up with $1 million, I can plug in A equals $1 million and then figure out what should P be. So let's go with that example. Say that in 10 years I need $1 million. And I can get a nominal rate of 3%, and I'll get it compounded monthly. Then we can calculate I to be 3% divided by 12. So 3% is our rate. We're compounding it monthly, so we have 12 compounds in a year. So 3% over 12 is 1 over 400, which is 0.0025. So that's our I value. And then additionally, our N value is the total number of times we will compound. And so that's 12 times per year times 10 years, or in other words, 120. Okay, so plug that into our equation that we've seen earlier. A equals P times 1 plus I to the N. And like I said, I want to end up with $1 million, so put in A equals 1 million. We calculated I, go ahead, plug that in, and go ahead and plug N in as well. So now we have everything plugged in except for P here. So how much must I invest right now today in order to end up with $1 million in 10 years? All we have to do is solve for P to find this answer. So go ahead, solve for P. What we need to do to solve for P, that means get P alone on one side of the equal sign all by itself. We need to divide both sides by 1.0025 to the 120. So go ahead and divide both sides by that, and we end up with P equals 1 million divided by 1.0025 to the 120. And then bust out your calculator, crunch that out, and you'll see that P is equal to $741,000 and 95 more dollars. Hard to say numbers today. Okay, so in other words, I need to invest that much money, about $740,000, in order to end up with $1 million in 10 years. Okay, so that's how it works with compound interest. What about with continuously compounding interest? We can do the exact same thing, just with the equation for continuously compounding interest. So A equals P times e to the RT. That's our equation for continuously compounding interest. And again, I can figure out P if I plug in A and R and T. So I need $1 million, so plug in A equals $1 million. Maybe the rate that I can get is 3%, and I have 10 years to get to $1 million. So how many dollars do I need to invest? We need to solve for P to find the answer to this question. So go ahead and plug in A equals 1 million, R equals 0.03, and T equals 10. So I have 1 million equals P times e to the 0.3. Now to solve for P, just divide both sides by e to the 0.3. So doing this gives us P equals 1 million divided by e to the 0.3. And then you can crunch that out and you'll see it's $740,818 and about 22 cents. All right, so we have seen how to find the so-called present value if I have some goal amount that I need to have in T years, or in this case, 10 years. So we can write these present value formulas more generally by just taking our equations from before and solving for p. So for our compounding interest problem, we had our equation a equals p times 1 plus I to the n. We need to solve for p, so we need to divide both sides by 1 plus I to the n. So we do that, and we see we have p equals a over 1 plus I to the n, or we can also write that as p equals a times 1 plus I to the negative n. So you can write it either way. These two things are exactly the same. Okay, so that's for compounding interest. For continuously compounding interest, let's do the same process, just solve for p. So start with our original equation, a equals pe to the rt. Solve for p by dividing both sides by e to the rt. So we have p equals a over e to the rt. And again, we can either keep it written like this, or we can write it like this. P equals a times e to the negative rt. These two things are the exact same. Okay, so those are our present value formulas. And again, we go get those just by taking our equations that we've been working with and solving for p.